Hello, everyone. My name is Ludovica Pannitto, and in this talk, I will be presenting our paper, Survey of Tools for Manual Linguistic Annotation, Supporting Diversity Through Interactive Exploration, which is joint work with Kaja Dobrovoljc and Bruno Guillaume. The work grew out of the UNIDIVE cost action. So in the paper, we try to address one of the needs that the community keeps running into, which is how do we find the right annotation tool for our project? Why a new survey? Well, manual annotation is still at the heart of language resource creation. We needed to build gold standards to train and evaluate NLP systems and to probe language models. The thing is, there are a lot of annotations tools, and while there have been previous surveys, they tend to be pretty high level. So this is the list of tools, and this is whether they're freely available. But what we really don't know is whether tool X actually handles features like right-to-left scripts, or whether these other tools can support enhanced dependencies, or let multiple annotator work at the same time. So this lack of practical detail is especially painful if you happen to be working on a less resourced language with spoken or multimodal data, or with complex layers of annotation. And in this situation, picking the wrong tool can bring you to, can set you back. So our goal was to fill this gap and not just document that tools exist, but document what they actually do and make this information easy to explore. To do that, we put together a structured questionnaire, which was made of 57 questions across 11 thematic sections, covering a lot of topics from software licensing to data format and to annotation types and workflow features. The data collection ran from September to December 2024 and was done in two stages. First, we reached out to development teams in order to gather more accurate and first-hand information. And then we distributed a broader call to the UNIDIVE cost action mailing list. UNIDIVE, which stands for Universality, Diversity, and Idiosyncrasy in Language Technology, is a cost action which connects researchers across Europe and beyond to work on multimodal corpus annotation and related framework as a community. In the end, we got 24 replies covering 21 distinct tools. 3 of the tools were surveyed twice, and we merged the responses. About half of the replies came from developers and half from users. The 21 surveyed tools cover a pretty wide range. We have general purpose environments like Inception or Elan, alongside with specialized editors, for instance, Arborator GRU or CoNLU editor. Our lens throughout the survey was UD and Parsim. So we were specifically looking at how these tools could support morphosyntactic and multi-word expression annotation, and we didn't systematically evaluate phrase structure, grammars, discourse, semantic layers, and more annotation landscapes that one could think of. The results are published in 2 forms on an open GitHub repository. The first is a structured TSV dataset where you can explore tools as rows and features as columns. And the second, which is the one I'm going to focus on, is an interactive web interface that lets you filter and explore the tools based on your requirements. The repository is split into 3 folders. There is a tool folder which contains 1 YAML file per tool, a data folder with a summary with the summarized TSV and JSON, and the interface folder which contains code for the web interface. And most importantly, the GitHub repo is of course open to contribution, and anyone can add a new tool via pull requests using the provided template. And I will show this in a second. So here is what the interface looks like. There are 3 panels. You can see feature filters on the right, organized into 7 collapsible areas. Then the tool catalog as tiles on the top left, and a detail panel for the selected tool on the bottom left. And all the 3 panels are resizable. So in the Unidive GitHub page, you can find the repository, which is called Corpus Annotation Tool. And as I was mentioning, it's divided into folders. The tools folder stores all the YAMLs. And by going into a YAML file, you will find all the information. This is the crucial part of the repo, as this information is what is used to then build both the interface and the dataset. If you want to add a new tool, in the template folder, there is a template YAML which you can use to add a new tool to the platform, and I will show you how. So the branch has now been pushed. There is a new branch which is called Add a Nota Flow, and I will start a pull request. GitHub pre-fills all the fields for the pull request to make it easier. So I will say that this pull request adds a new tool. A Nota Flow. So it does this, and then there is a checklist which makes sure that I added exactly 1 YAML. I did not edit the results. I kept all the fields. I used correct format for URLs. I used correct format for booleans. I checked the list fields that I use in YAML list, and I optionally run this script to show the update on the dataset. And I might want to share information with the maintainers, which I'm not going to do in this case. So I'm going to create a pull request. The pull request appears, and someone from the maintainers team will take care of looking into it and checking it can be merged. So in this case, it's gonna be myself. I'm going to merge it right away. So let's confirm the merge and delete the branch that added a Nota Flow. A number of continuous integration steps are being done. So the commit added the new tool to the tools, which now is building the page with the updated tool list. The page's build and deployment has finished. So if we now go to the interface, we can see that a Nota Flow has been added automatically to the interface with all of the features that we inserted into the YAML. And this is exactly also the thing that is happening if you update information on an existing tool. The steps you should take to open the pull request are in the main README of the repository, and also from the interface you can go on the About page and find a description of the repository, the citation for anytime you might want to use our tool, and direct links to information for adding or updating tools. So here you can see the feature selection in action. When you select a feature, matching tools are pulled to the top and highlighted, and the rest is grayed out. And you can combine multiple features, and the counts will update live to tell you how many tools are available with your selection. If you click the plus on a tool tile, you get its full details in the bottom left panel, and all these features light up in blue on the right, so you can immediately see how it maps into whatever requirements you have set. Now for the findings. On the software side, things actually look pretty good because 17 out of the 21 tools that we survey are actively maintained, 18 have public repos, and are open source. And this looks like a healthy ecosystem in our opinion. Where it gets a little bit trickier is deployments because most web-based tools, 14 out of 21, require self-hosting. Only 3 are freely accessible online with no setup. So in practice, the barrier to getting started to work collaboratively is a little bit higher than we might desire. And we also found limited support for multimedia data. Only 5 tools are able to handle audio, video, and images. And very few tools allow for Git integration. And we believe these are gaps for modern annotation workflows. For what concerns language support, all the 21 tools are language independent and UTF-8 compatible, which is a solid baseline. 17 claim right-to-left support. And interface, on the downside, interface localization is almost non-existent because almost all tools only provide English interface, which is something we should be working on to support greater linguistic diversity. Workflow automation is also limited. Only 7 tools offer automatic pre-annotation and just 5 offer recommendation systems. Collaborative annotation and inter-annotator agreement calculation exists, but not they are unevenly implemented across tools. And these are the things that could matter when projects need to scale up. For universal dependencies, the core layers, so lemmas, universal parts of speech, morphosyntactic features, and basic dependency relations are well covered, with most tools supporting them. But the more advanced features like enhanced dependencies or the availability of empty nodes are only supported by a minority of the tools. Built-in UD validation is available in just 5 tools. For Parsim, the picture is spottier because discontinuous multi-word expressions are only supported by 5 tools. And Parsim consistency is supported by just Parsim consistency check is only supported by 1 tool. So to wrap it up, we surveyed 21 annotation tools. We documented more than 50 features for each of them and made everything available as an open dataset and an interactive platform. The good news is that the ecosystem is healthy. There are a lot of openly developed tools maintained and active, but we found some gaps. Advanced support both for universal dependencies and Parsim is uneven. Workflow automation is not implemented in many tools, and multilingual usability is not evenly supported, especially when it comes to interface localization. The take-home message is that we want this GitHub repo to be a living resource. So we set up a contribution workflow, which is already in place, and we are counting on the community, not only the Unidive network, but all the ones that are interested in developing resources and are involved in developing tool to help it grow and keep information as accurate as possible. The next steps will include expanding to other annotation paradigms, looking at LLM integration in tools, and go into more dedicated usability studies. Thanks for watching. Questions are very welcome, and see you at LREC.